So it's back to some video learning. Tonight we're going to talk about multiplying matrices. And this does get a little tricky, but the good news is because it's a little tricky, you won't be multiplying giant matrices together, at least for me. So, the rule, in order to multiply two matrices together, matrix A times matrix B, the number of columns of matrix A and the number of rows of matrix B must be equal. So let's take an example. We have matrix A, and if I say matrix A is a 3 by 2, that means it's got 3 rows, 2 columns. So let's see here. 3 rows, let's make them 3, 2, 1, 0, 4, 9. Okay, so matrix A is a 3 by 2. And matrix B is a 2 by 4. So a 2 by 4, let's say it's 2, 1, 4, 5. That doesn't look like a 5 very much, but 4, negative 1, 0, 3. Okay, so here I have matrix, and this, is a 2 by 4. So I can multiply matrix A by matrix B because matrix A is a 3 by 2 and matrix B is a 2 by 4. So my interior numbers are equal, so it's a big old check and it works out. Now the interesting thing is my answer matrix will be a 3 by 4. Okay, so I can multiply matrix A and matrix B together in this order. However, I can't multiply matrix B by matrix A because matrix B is a 2 by 4 and matrix A is a 3 by 2, and lo and behold, 4 and 3 are not equal. Can't do it. Can't multiply. And here we have a little rendition, a contemporary rendition of the Scream compliments of The Simpsons. So how do we do this multiplying stuff? Okay. Let's say I have two matrices. I have matrix, the first one, and I'm just going to put in letters because I know math students love letters. It's A, B, C, D times another matrix, which is W, X, Y, and Z. Notice they are both 2 by 2 matrices. They don't have to be, but it makes life easier. I can multiply them because those two numbers are equal. Okay, so how do I do it? For my first element, this will be my first element. What I am going to do is I'm going to multiply this element and this together. So A, W, and then I'm going to multiply B, Y together. And I am going to add those two products. So that's element 1. So it's essentially first row, first column. Now for this element, I'm going to do the first row, second column. Notice it's in the first row, second column. And this will be A times X plus, so A times X plus B times Z. Okay? Now moving on to this element here, I am going to have, this is in my second row, first column, so I do C times W plus D times Y. And lastly, in this fourth one, this fourth element, which is in the second row, second column, I do second row, second column. So C times D. No, that is so wrong what I just said. So let me erase that. I do C times X. So C times X plus D times Z. And here I have my resulting matrix, and it's also a 2 by 2. And it works out because the outside numbers are both 2's. Okay, so let's do some numbers here. Let's say matrix A equals, I'm going to make it a 3 by 2. 0, 1, 2, 4, -1, 3. So this is a 3 by 2. And matrix B, I'm just going to have a 2 by 2. So I'll make this 8, 7, excuse me, -2, -2, that's a 2, 4. So if I multiply matrix A times matrix B, this is a 2 by 2. First of all, my answer matrix will be a 3 by 2. And I can multiply these together because my interior numbers are equal. Okay, so let's do this. First row, first column. First row, first column. 0 times 8 plus 1 times -2. Now we'll do, I'm sorry, I just blanked out. First row, second column. So I do 0 times 7 plus 1 times 4. Okay, moving on, I'm going to do the second row, first column. So 2 times 8 plus 4 times -2. And now I am going to do second row, second column. So I do 2 times 8 plus 4 times 7. Moving right along, I'm in the, ooh, this is a yucky color. I'm in the third row, first column. -1 times 8 plus 3 times -2. And last one I do, let's go back with our purple. Last one I'm going to do, third row, second column. So -1 times 7 plus 3 times 4. All right, now let's simplify this bad boy. So my answer matrix, 0 times -8 is 0, plus 1 times -2 is -2, so this will be -2. This one, 0 times 7 is 0, 1 times 4 is 4, this will be 4. 2 times 8 is 16, 4 times -2 is -8, 16 and -8 is +8. 2 times 8 is 16, 4 times 7 is 28, so 16 and 28 is 44. -1 times 8 is -8, plus -6 is -14. -1 times 7 is -7, -7 plus 12 is 5. So there you go. That is multiplying two matrices together. Alright, so some properties of matrix multiplication. We know that matrix multiplication, well, let's talk about, okay, let's rewind. We know that matrix multiplication is not commutative, because A times B is not the same as B times A. So we don't have to worry about the commutative property. It is associative. So if I am multiplying three matrices together, it doesn't matter the order in which I multiply them. The left distributive property if I multiply matrix A times the sum of matrix B plus C, that's the same as multiplying matrix A times matrix B plus matrix A times matrix C. Notice I'm multiplying A from the left, so A has to come before both B and C. The right distributive property, if I'm adding two matrices together, and then I'm multiplying it by another third matrix, matrix C, that's the same as multiplying matrix A by matrix C and matrix B by matrix C, and adding them together. Notice, again, I'm multiplying on the right, so the matrix that I am multiplying by has to be on the right side of the other two matrices. The associative property of scalar multiplication. If I am multiplying a scalar by the product of two matrices, that's the same as multiplying the scalar by the first matrix and then multiplying that product by the second, or multiplying the scalar by the second matrix and then multiplying to that the first matrix. So I've got, let's see, some examples. I will do the associative property, AP. That's a B, AP. So this is like saying that if I multiply a matrix by the product of two other matrices, I'm going to get the same answer as if I multiply the first matrix by the second and then multiplied that product by the third. And I am not going to go through all of this step by step, simply because my video would be, I believe, hours long. So there is the associative property. And the other one I want to show you, the other example, is the left distributive property. So if I am multiplying this matrix by the sum of these two matrices, that is the same as saying I'm going to multiply the first matrix I'm going to multiply the first matrix by the second matrix and then add that product to the product of the first matrix times the third matrix. So those are the two examples I wanted to show you. Now, let's see here. A couple of more examples that I want to do with you before I send you on your way and to multiply matrices on your own. So -1, 0, 3, -4 times -3, 3, 5, 0. First of all, can I multiply these two? This is a 2 by 2. This is a 2 by 2. Oh, look, these two numbers are the same, so yes. Alright, so let's just do this. First row, first column. So -1 times -3 plus 0 times 5. First row, second column. -1 times +3 plus 0 times 0. Second row, first column. -3, whoops, +3 times -3 plus -4 times +3, and then second row, second column. 3 times 3 plus -4 times 0. Okay, let's come up with an answer here. So First of all, I'm going to end up with a 2 by 2 matrix. That'll be my answer. -1 times -3, so that's 3. That's 0. So this is 3. This is -3. This is -9 plus -20, -29. And this is 9, just 9. Okay. So there's my product matrix. Now I was going to show you another example, but I'm not going to. Because, oh, why not? Okay, let's do another example. Let's do a 2 by 2. And I'm going to multiply that by a 2 by 1. So 2 by 2, 2 by 1, the answer, the numbers in the middle are the same. I can multiply. My product, my answer matrix will be a 2 by 1. So, first row, first column. 2 times 4 is 8. 6 times 8 is 48. 8 plus 48 is 56. Second row, first column. -3 times 4 is -12. 7 times 8 is 56. 56 plus -12 is 44. And there is my answer matrix. And look, it's a 2 by 1. And here we have a classic cartoon. Yay, Calvin and Hobbes. I will let you read it. And as you're reading that, I've got a couple of examples I am going to give you to try for homework. Try for class tomorrow. Okay. So, and I won't give you really hard ones because that's just mean. I will give you, let's see here. I would like you to multiply these two. And, excuse me. All right, good luck, and I will see you in class.